I think we have mostly everybody on board. So again, welcome to this webinar about third-party control. In today's webinar, we're going to talk a little bit more about how AHM64 or all of our digital products can be used with a Crestron system. We have a special guest from Crestron, Ara Seferian, where we have recorded an interview. Hi, Ara. And we're going to show you the interview, and Ara is here at the end from the webinar to fill up the Q&A if you might have questions. For those who have watched our webinars during this week, there's a Q&A button in the bottom of your Zoom window. You can ask your questions there and we will answer them at the end of the webinar. So let's start. So third-party control. All of our digital devices, Avantis, Q, SQ, AHM, have an Ethernet port. And that Ethernet port, in most cases, means you are able to be controlled by a third-party controller. So in our case, we use this Ethernet port to send and receive simple serial messages, which controllers can receive and process to do something with it. So most people use a control system to remove all the clutter of all the remotes, the touch panels, whatever they have from different devices, and bring that back into one device. So again, we had a little chat with Ara. I will show you the interview, and if you have any questions afterwards, please let us know. Thank you. Hi, Ara. Nice to see you. Nice to be here. Can you tell me a bit more about you and what you do for Crestron?
Sure. It's thank you for having me. Hello, everybody.
Welcome.
Yeah, my name is Ara Seferian. I am a product manager here at Crestron. I've been here for 20 years. I have been in the industry for 28 years. So I actually started as a dealer, working for a dealer, doing wiring, installation. Eventually moved into programming, and then was hired by Crestron, to come and work for the company. So I manage two aspects of Crestron in the product management group. The first part of my job is to manage an application called AV Framework, and that's an application that dealers can use to program our control systems using nothing more than a web page. Mm-hmm. It's a commercial-based application. So for those of my dealers here that are familiar with Crestron Home, which is the residential configuration application, this is the commercial side of that. So that's part of my job. And then a second part of my job is to manage third-party integrations, and more importantly, a driver framework that allows people to build drivers for third parties. Hence the reason why I'm here talking to you today.
That's nice. So we have the right person to talk to today.
Yes, I am definitely the right person. If you've read my bio for any blogs that I've written, I've pretty much spent my career developing control for third-party devices using Crestron hardware. So it's something that I'm passionate about.
Nice, that's a good one. So a lot of our users are new to control systems. Can you explain a little bit more about what a control system is, what it does, how can we use it?
Certainly. The funny part of this is that I've been in this industry for 28 years, and I have family members who still don't understand what I do, as I'm sure a lot of us are in that position. So a lot of times, in order for me to explain what a control system is, I actually step back and I tell my family members to take a look at their coffee tables, or their tables next to their sofas, and to look at all the different remotes that are spread out on their coffee tables and such. And essentially what a control system is really just a universal translator. And it allows you to create a single interface or a single way to communicate with multiple pieces of hardware. Now, it doesn't matter if that hardware is in your house or in a boardroom, conference room, but the control system basically allows you to communicate with third-party hardware in whatever mechanism is required to control it. So if it's infrared, if it's contact closure, digital, outputs, digital inputs, analog outputs and inputs, any type of control mechanism or control method required to interface with a piece of hardware is supported by a control system. So it's like a black box, and it's a universal translator is what it essentially really is.
So that also means that you can control any device out there in theory?
That's correct. Yeah. There really isn't an API or protocol or a communication method that can't be supported by a control system. And even if the control system doesn't natively support that control transportation or transport, like let's say MIDI or DMX, right, for lighting, you can purchase any type of a third-party piece of hardware that the control system can then communicate to, and then that in turn could communicate to something using MIDI or something using DMX.
Yeah, okay. No, that makes sense. So that also sort of answers the question a bit on why would you need a control system, or is there anything else why you would need a control system even more?
Sure. So one of there's a number of benefits to when you bring a control system in to communicate with hardware. One of them being what I mentioned earlier, which is taking a whole bunch of remotes and unifying that into one consistent experience for the end user. Yep. So it allows you to present to your end users one unified or one experience to control all the different pieces of hardware. It'll be completely consistent, right? A lot of these devices have apps, mobile apps that you can install on your phone, and that becomes a poor user experience, obviously, because if I have to open and close a different app for every device that I want to control, it doesn't lend itself to being a very fluid or a very nice experience for an end user. So by using a control system, that universal translator box, we can present one consistent interface and control, anything that you really want to communicate with. The other thing the control system does is it extends the capabilities of what you can control with a device, because the control system has a logic engine inside of it, and it's programmed by a programmer. So that means I can do things with a piece of hardware that may not natively be supported within the hardware itself. In other words, you can create sequence of events. You can react to things that are happening in the environment. All of those types of things can be inside of the control system and may not be supported by the device itself.
Yeah, I can imagine, if I recall correct, there are systems where, for example, a boardroom, the projector is out of order, and then a control system can automatically reassign that boardroom to another boardroom through the calendar system, for example, if I'm correct.
Sure, yeah. Things like room combining, even reacting on weather events, raise and lower the shades based on the forecast that's happening outside, or there's, when you bring the control system in to your control, let's call it equation, there really is no limit to what you can do. You're only limited by your imagination at that point.
Yeah, okay. No, that makes sense. Hey, and Crestron is one of the big players on the market. There are many control systems out there. So what makes Crestron unique or special, or why is Crestron that big?
Yeah, Crestron has been around for over 40 years. We started very early in the control and automation technology. So we leverage a lot of that experience and a lot of the things that we've learned over the years in the products that we create. And that makes us unique only because we have so much experience in developing hardware for the control industry that gives us a very good perspective on what needs to be built, and also how it needs to be programmed for by our integrators and by our dealers. We also are one of the few manufacturers that actually manufacture all of our products. A lot of our manufacturers tend to go out and purchase other companies, or they ODM products and then put their name on it. Crestron actually manufactures almost all of its products. We have a very large manufacturing facility, over 1 million square feet. And everything that we manufacture, we do ourselves.
That's a good one. Good one. Hey, how does a control system interact with other devices? So how does it communicate? You said we can control almost virtual everything. How do we do the communication?
Sure. So I actually put together a diagram that we can talk about here, and it's probably in the realm of what you can do with a control system. This is on the simplistic side. So this is one of our what we call our CP4. It's a control system that's a single RU unit, and this is an image of the back panel of that device.
Yep.
So what I've done is I've shown a few different ways that the control system can control a piece of hardware. The first are simple contact closures. The relay outputs are connected to a projection screen, so this could raise and lower it. I have a wall sensor going into a digital input on the control system. And interestingly enough, a lot of the divisible spaces when we get into wall sensors are actually connected to the lighting system. So, this is another benefit of having a control system in your application, because we can communicate with the lighting system and then get the state of the wall, whether or not a divisible room wall is open or closed. I also put a Blu-ray player on here just to show that we have a number of infrared outputs that we can use to control a device. There's this particular control system has 3 serial ports. Yep. So I have a serial connection going to a projector. Now we support RS-485, RS-232, and RS-422. So we support all of the common serial protocols that are available. And of course, we support Ethernet communication with any type of device that has an API to communicate. It doesn't matter if that communication requires authentication. We support all of the common authentication and encryption protocols to communicate with the device. The other thing that we also have is our own proprietary wired bus, communication bus, and that's what that keypad is there. So, if you can imagine, that keypad could have any type of button on it and could trigger a sequence of events in the control system to recall a preset on a DSP, lower a projection screen, really, anything that you want to do is available when you're programming this.
That's a nice one. Okay, nice. So we know how to get in and out. How do you program this? If I'm correct,
Sure.
There are 2 types of programming it.
Yes. So actually, let's talk about that. So Crestron actually provides 3 different ways to write a program for our control systems. And I'm just talking from the aspect of logic right now. The user interface is created using another application that we call VT Pro. And more recently, we introduced support for HTML5. So you can actually create a user interface using common web editors. But from the logic perspective, we expose 3 different ways to write a program for your control system. One is based on a programming model that's actually been around for much longer than I've been in the industry. So, this is an over 20-year-old model to program a control system. And what I'll do is I'll bring this up to show you, because I think it makes more sense if I open this up. And so the application that we're looking at here is called Simple Windows. And the entire programming model of this application is based on logic symbols. So going back many, many years when I first started in this industry, this application was actually in DOS, and we used to call it the workshop. And back then there were no real programmers. We didn't have the industry was filled with audiovisual technicians and people that understood wiring, how to connect a wire from point A to point B. And we developed our programming language based off of that understanding. So this language was really built for wiring technicians because they understood that they needed to connect something from point A to point B, almost like programming a DSP when you're wiring up your blocks inside of a DSP programming environment. So in this case, we have these logic blocks, and I'm just opening up like something like a NOT gate. And instead of a wire connecting these blocks together, it's actually a signal name. So, you give the signal a name, and that's how you connect your blocks together. So if I looked at something like a touch panel block, you would see that I have a button coming from my touch panel, and it has a name on it called preset take button. And if I see where that's connected to, you can see that the button press comes in from the touch panel and it goes into the Allen Heath module to control the AHM64. And it's basically triggering a preset. And that's essentially, the gist of this programming environment. It's all based on these blocks, these object blocks, and they're connected together with signals instead of wires. So this is really the fundamental way that dealers have programmed our control systems going back more, almost 30 years, for how this was set up. And then in addition to this, over the years, we realized that more complicated logic required a more complicated way to program the systems. Not more complicated, but an easier way to program the systems. And that's syntax-based programming. In other words, over the years, we realized that more and more computer programmers were actually coming into our industry, and they are more familiar with computer languages. So they like to write in what we call syntax language, if-then statements. So Crestron actually introduced its own proprietary syntax language called Simple Plus. And it's very similar for anybody who's familiar with JavaScript. It's very similar to JavaScript, but it's a syntax-based language, and all of the syntax is syntax that we developed. And then more recently, we went into a more standards-based syntax language, and that's C#. So we provide 3 ways to program our control systems. You can use the logic, the ladder logic or object block programming environment, which is Simple Windows. You can use Simple Plus, which is our own syntax language, or you can use C#, which is a more modern syntax language. It's all based on Microsoft.NET.
Yeah. Okay, makes sense. Okay, that's a good implementation. At least we know how to program it. So we have developed a module for AHM64, our DSP. Can you show us a bit how that works in simple?
Sure.
And how we reprogram it?
Yeah, absolutely. So I'll go back and share that same Simple Windows environment because I actually happen to have the module open. And so, by the way, the module is available on Crestron's application market. And if you actually just did a simple Google search, if you just typed in application market, Crestron's application market actually comes up in one of the top search results. So this module is available there. And when you download the module, as with all of the things that we publish to our application market, it comes with a sample program. So what I've essentially done here is imported that sample program, and then you can see how it's organized, and I'll collapse all these folders here. You can see how it's organized between the various aspects of controlling your DSP. So we have a module to control the presets in the DSP. And as I mentioned earlier, remember, these are just, the signals are the wire that connects everything together. So, this signal here, the take input on the module is coming from a button press from the touch panel. And This input here that's labeled preset and it's colored in red, that means that this is an analog value. It's a numerical value. So, if you're thinking about this in terms of logic, I set this signal to some value, 1 through whatever, as many presets are supported. And then I trigger this take, and then the preset gets recalled in your DSP. So, this is the preset module. Another module was developed for source select. So if we look at here, again, it's an analog input. So I set this signal to some value. And then when I want to select that source, I trigger this take input. And that's a source selection. And there's also a module for levels. And so there's a number of these in here, but these are all the same module. They're simply being reused for as many inputs, zones, and groups that you want to control. And a lot of these modules that are created have a parameter field, right? So in this case, you can change whether or not you want to control an input, a zone, or a group. And then there's another channel parameter that you fill in here. And then this module, then exposes the ways to control the levels, and you can poll for status here too. And then it provides feedback also. Okay. So that's for levels and mutes. There's another one that was developed for the cross point levels. So again, it follows the same format. The difference here with a cross point, obviously, is you need an input and an output, right, to define your cross point. So that's a module for controlling cross points. And then there's also one for playback that was developed. So, all of these are part of the sample application that is on the application market. And then to communicate with the DSP, you would drop in what we call a TCP client symbol. So it's just basically a symbol that allows you to communicate with a device over Ethernet. Yep. And then these signals here get connected to those modules. And it's as simple as that. I mean, it really is. I'm probably oversimplifying it because I've been doing this for so long, but it really is like I am more comfortable in simple windows, even though, I spend a lot of time programming in syntax and C# and JavaScript. I'm still more comfortable in this environment. And it's simply because I started as a wiring technician, and my brain probably, is more comfortable in this type of environment.
Yeah, okay. But as far as I understand, users who want to do it in syntax can use this module also as an example for what they want to use in syntax, if I'm correct, right?
Yeah, that's correct. So the way that the module was written is even if the person that developed your driver wrote the whole thing in syntax code, because they could do that, what we do is we wrap all of that syntax code in what we call a wrapper. Yep. And then that's how it's used in simple windows. But if somebody wanted to control your DSP using nothing but syntax, they don't have to use that simple Windows wrapper. Yeah, they can use what was written in syntax in C#, and they can use that in their custom program rather.
Hey, then we get a lot of questions. Most DSPs communicate in a two-way. So if I send, for example, a fader level to a DSP, the controller expects the value back before it adjusts their fader value. Our software guys have decided to not give that feedback, and instead of using UDP messages, using TCP/IP messages to the DSP. What's the advantage or disadvantage on doing it that way instead of sending UDP messages over the network?
Sure, there's actually a huge advantage. So the UDP protocol is what we call a fire and forget method. So in other words, when you send out a message over UDP, there's no guarantee that it's going to reach the destination. So the message goes out on the wire, and then that's it. That's the end of it. You don't hear back from the device. And as a matter of fact, at the lower level, the stack that's communicating over UDP doesn't know if that message even made it to its destination.
That's why you want to have the feedback from the DSP to make
That's
sure.
correct.
Yeah.
Yeah. So when you use TCP at the lower level, there's retry mechanisms and guaranteed of delivery. So when you send a message using a TCP stack and that message goes on the wire, it's guaranteed to get to the destination. If there are any network anomalies that are occurring, the stack itself keeps retrying that message. And when it doesn't reach its destination, there's events that are bubbled back up into the application so they know that the message never made it to the destination.
Yeah, yeah. And you can also, because we don't reply with the physical status, you can also acquire the DSP for the actual value, right?
Yep. So every one of those modules had a poll input, right? So you saw that when we were going through the simple windows. So you can certainly, when you first connect to the DSP, you can poll the DSP to get status of everything, and you can poll periodically to get updates. It's essentially up to the programmer how he wants to keep in sync with the DSP.
Yeah. Hey, and is there anything you noticed on the DSP or control side on the AHN DSP or the control module in that case?
No. It actually it's well written. It works really well, and I don't think anybody is going to have any problems using this, especially if you just start with a sample program.
Yeah. Okay, that makes sense. Hey, and if I'm new to Crestron and I want to, or I have a customer who wants to put a Crestron system in their building or in their house, how does that work? Can I get training? Can anybody help me? Do you have a sort of network for programmers? How does that work?
Yeah, that's a great question. So Crestron hardware is all sold and installed by our dealers. We have an integrator network. In addition to that, we have what's called a Crestron service provider network. And those are individuals who just provide programming services for individuals who are looking to get hardware programmed and even installed. So, there's nothing preventing any of our Allen Heath customers here from becoming a dealer. We can certainly set anyone up with a regional sales manager, and they can, talk people through the process of what's involved in becoming a Crestron dealer. But if there is somebody who wants to use a Crestron control system with some Allen Heath hardware and in a particular project, the Crestron service provider is really a great place to start. There are thousands of Crestron service providers all over the world who can provide programming services, and a lot of them can even purchase hardware. If some hardware needs to be purchased.
Yeah, and in that case, with that system, you also don't have to be afraid that that service provider is going to take away your customer because it's only providing that service, right?
Yeah, that's correct. Yeah. The service provider is there simply to provide programming services for Crestron hardware. They're not there. They're not a dealer per se. You're right. They're not looking to create and install and create an entire system or entire project. They're a service provider, hence why we call them service providers.
Hey, is there anything you would like to say to people who are starting with control systems? Because sometimes it's a big, you explained a lot today, but sometimes it's a big forest with all things you probably forget or don't know.
Start small.
Yeah.
That's like, don't because there'll be, the sample programs are available on our application market. Don't get yourself into a rabbit hole when you're trying to look through the sample programs. Like focus on specific areas that you're interested in first. In other words, if you want to learn how to control a level in the DSP, don't look at the rest of the modules that are part of the sample program. Focus on one area first. Understand how the workflow works for that one particular area, and then move on to the next. in essence, our control systems only communicate internally using one of three signal types.
Yep.
You either have a digital signal, which is high or low, it's either on or off. You have a what we call an analog signal, which is a number, it's a numerical value, or you have a serial signal, which is just text or ASCII text. So if you understand those principles and you start looking into some of the sample programs on our application market, you'll realize that it really does boil down to very simple concepts. There's a lot of symbols, a lot of logic symbols that are available in our programming environment. And out of all of those logic symbols, most dealers or most service providers, only use a small handful of those. So, a lot of times you get overwhelmed when you look in our library and you see thousands of symbols in there. You can get lost, lost in the weeds. So, my advice to anybody starting out is always start simple. Understand what a button press, how do I get a button press from my user interface? It doesn't matter if it's a touch panel or a keypad. How do I get my user interface button press into the control system? And then how do I make that button press do something on a piece of third party, piece of hardware? Start with very simple concepts, and then you'll be able to expand beyond that.
Yeah, you should start learning simple and then expand from that side.
Yeah, well, and there's a lot of videos available for anybody really interested in Crestron control system programming. Yep. There's plenty of videos on YouTube. A lot of our dealers have published videos, of themselves programming systems.
Oh, nice. That's always useful to learn stuff there in that case. Okay, cool. Hey, and going from very small to maybe big, what's the most interesting install you ever did or witnessed or been a part of in your time with Crestron?
Yeah, so because I worked for the dealer for 9 years before I came to Crestron, and even my first few years at Crestron, I was doing programming. There's a couple installations that I found very interesting and that I actually loved. The first one is going back quite a number of years, and I actually developed a show control programming environment for Caesars Casino in Atlantic City. So the dealership that I worked for was in South Jersey, and they had another office in Maryland, and we did a lot of the casinos in Atlantic City. So I developed a programming, like a show control programming environment for the AV techs at Caesars that would allow them to create shows, triggering lighting and sound and all types of show events using nothing more than a handheld remote control. And back in those days, we didn't have syntax language. So I wrote the entire thing, in simple windows. Like I said, I'm more comfortable in that environment. And it was really, at the time, it was really unique because it allowed the AV team the ability to walk around while the show was being rehearsed, and they could actually get the timing of the events that they were trying to learn exact to the shows, because they could walk around with nothing more than a handheld remote. So they would set up all the cues ahead of time, and then they would, basically get on the stage with the performers, and they would press a button when they wanted to save a specific cue at a specific time, and it allowed them to really fine tune the show control. And that was a really interesting and I was very proud of that project.
And when was this? Because now this is, for a lot of users, this is like, okay, we have a phone and we have a touch panel.
This is over 25 years ago. Yeah,
so that's before we had mobile phones with touch screens and stuff like that.
That's correct. Yeah, the handheld remote, it wasn't a mobile phone. It was a Crestron wireless, RF, remote with a bunch of buttons on it. Yeah. And it was it was an interesting project. And then when I started to work with Crestron, I don't want to say I drew the short straw, but Microsoft was standardizing Crestron hardware across their campuses globally. So I spent a year in Redmond, out in Washington, at the Microsoft campus, working on that project. And that was a really cool project because as a result of that project, we received multiple patents for room scheduling because we co-developed some technology with Microsoft. And they're a great partner of ours today. Because of that early work. So I was very proud of that. And it was, it's a large project. It was, at the time, it was 10,000 conference rooms. And I think that's exploded into many more today. But yeah, that was a really interesting project for me.
Well, that's always good to know. And especially when you say start little, then probably the 10,000 rooms they have plus now, it's probably not the right place to start. It's a good one to hit. Nice. Hey, anything news we can expect from Crestron soon? Which can be interesting for us.
Yeah, anything interesting. So we have, and I haven't mentioned this. I mentioned it earlier, but I haven't really talked in depth about it. So one of the things that I'm responsible for is what we call this driver framework, and we haven't talked about this yet. So what we did with Allen and Heath is we created this simple Windows module, and and also we expose the ability for a simple Sharp or a C# programmer to use that same type of module. But we have something that's called a driver framework. And so what is a driver framework? Our driver framework is a framework that standardizes the way we control or we talk to third-party devices. So what that really does is it makes it a lot easier for applications like Crestron Home and AV Framework, which are the applications I mentioned earlier, to communicate with third-party devices because it standardizes the way that we communicate with those devices. So right now, the driver framework is limited in the types of devices that it can communicate with. Right now, we don't support DSPs, unfortunately, which is the whole reason why when we worked with you guys, we went the route of a simple Windows module for that. But we're actually in process of adding support for DSPs and audio processors to the driver framework. So what does that mean? That means that applications like AV Framework and Crestron Home will be able to communicate with DSPs. And that's something that we can't do today. So right now, the only way for a Crestron control system to communicate with a DSP is with a custom program, using that simple Windows programming environment. But imagine if you were able to communicate with a DSP using nothing but a web page, right? So you could configure your control system with a web page and then be able to communicate with a DSP or an audio processor. So that's one of the big things that we're working on right now. So that's and we're adding more device classes to the driver framework all the time, but DSPs are the one that's in our immediate future. And we have a whole software development kit that we created so that people can build drivers for all these devices. So, it makes it a lot easier to actually build a driver with our software development kit.
Nice. Okay, so it will become easier then, or less hardware dependent on how you program your system.
Yep. And I mentioned earlier that our user interfaces now support HTML5.
Yep.
So that was moving to a more standards-based technology, and we're working on creating much easier ways for our dealers and integrators and service providers to build user interfaces for HTML5. So that's another very exciting thing that we're working on internally.
Nice. Good to know. Good to know. Well, I think we sort of have shined a light on the Crestron systems. Thank you very much for your time. I don't know if you're going to be here for the Q&A.
Yes. Absolutely.
So if we have questions for you, we can ask them. If you don't, or not going to do them in the Q&A, we'll probably find a way to get your digital information to Ara and back to you again. So for now, thank you for speaking, and I will see you in the Q&A a little bit later.
Absolutely. I'm looking forward to it.
Thank you, Ara.
Sure.
So that was our short interview with Ara. I hope that gave you a lot of information. So a few things we can take back from that interview is that if you want to play around with that Crestron driver, you can download it from our website. On the third-party control website, the drivers for DLive, Avantis, Q, SQ, and A&HAra are available from our website. And they're also available from the Crestron application market, which are already explained. Just hit Google Crestron application market and will probably be one of the few top hits you have. Select modules, manufacturer, and we're under A from Allen Heath, and you can find them. On the same webpage from Crestron, you can also find their service providers, which, especially when you start out, can be very useful. As you can see, Allen Heath is in Falmouth, UK. There are already 5 service providers in the neighborhood there. So it's an easy one to find. So I think we have a ribbon with the Q&A. Nick, I don't know if you're here. I don't see many questions coming in. We probably have answered most of them. Hi, Nick.
Hi, Martijn, and hi, Ara. Thank you again for the interview and all of the information. Yeah, I think it's been very comprehensive in explaining the Crestron system on one side and what you can do with the AHM64 or Allen Heath equipment in general on the other. We had a couple of questions coming in through different channels, and one of these was whether the Crestron system with the control module for Allen Heath devices could potentially control different devices at the same time, so like an AHM64 and a DLive or an SQ mixer at the same time.
Ara, do you want to take that one?
Sure. The control system isn't really limited in what it can control, since it can really communicate with any type of third-party device that has some way to communicate with it, whether or not it's through an API, through an Ethernet connection or RS-232, whatever it is. But you know, you're really limited by the memory that's available in the control system, and you know, basically the resources that get consumed at runtime. So you know, you can communicate with as many different third-party pieces of hardware as will run in the control system. So in other words, you know, with the footprint of this module, like the Allen Heath module is very small footprint. You could have hundreds of those modules in a control system program very easily, and communicate, and you know, with hundreds of devices. A lot of our larger control systems are what we call multi-slot. So that means they support multiple programs. So, you know, each programming slot could communicate with hundreds of devices, and you have 10 slots available, you know, in a larger control system like the CP4. So, yeah, controlling multiple pieces of hardware is definitely supported, and very large systems are supported in our control systems.
And similarly, the reverse question in terms of if you have multiple Crestron touch panels and keypads and so on, you can keep adding control interfaces without necessarily increasing the workload on the mixer side or AHM64 side, I presume, because it's still a single connection between the Crestron main unit or server and the mixer, I guess.
Yes. Exactly. Yes. Yeah. It's the cool thing, you know, the other benefit of having the control system, aside from the ones that I talked about in the interview, is the fact that the control system is making that single connection to the hardware. So, you know, the number of user interfaces or peripheral devices that you're using to interact with the control system don't affect the communication between the control system and the Allen Heath hardware. So you're basically, you know, that's your gatekeeper, your gateway to the device almost.
Thank you for that. There's a question from Giovanni about feedback, which I think you guys touched on, particularly with faders, volume faders, whether the module will give any feedback back. Ara or Martijn, I don't know if you have an answer to that.
Yeah, I think there are two ways. One is that you can pull or acquire the AHM for the fader level. And when you move a fader in software or you move a fader around on one of our IP controllers, it will give feedback to the controller, and then the controller can do with it what they want to do with it.
And I think that's all of the questions from this session. I just want to echo what Martijn said at the start. So if you haven't checked out the full schedule of webinars and sessions, please do so. Martijn had got a slide there ready. There's still a bunch of exciting topics tomorrow in the program, so feel free to register. And on the same page on the website, you can also book a one-to-one meeting with the Allen Heath tech marketing team or the team in the US and other territories if you want to discuss a specific project requirement or product. So thank you everyone for attending. Thank you very much, Ara and Martijn, for the presentation.
Yeah, thank you. And Ara, thank you for your time, and I hope to see you soon somewhere in real life.
Sure.
Thank you very much.
Thanks for having me.
Bye-bye.